Pixel's technology has been shipped in hundreds of millions of units over the last 10 years, largely used for document content, typically rich file content of the formats that found in Office and photos as well. The consistency for the user is they can break away from the model of looking at file formats such as .pdf or HTML and start working with use cases. They want to read a book. The book could be in a PDF format. They want to look at a brochure. The brochure will be in a PDF format. They don't have to think about the format, they simply get on with the task at hand. The responsiveness of the Pixel technology matches or exceeds that on a desktop PC, even without the specialized hardware we see on a desktop PC. For example, changing the pages here is nearby instantaneous. As I'm stepping through here with a simple gesture along the bottom of the screen, you can see the responsiveness is remarkable for a device of this age and capability. Although the technology is designed to cover that kind of content, it's perfectly capable of rendering more interactive content such as video and audio and animations. In fact, it's rather easy to interact with video and pan and zoom it once you've dealt with the complexity of these web pages and Office documents. Here we can see PC-style video panning and zooming in real time again with a simple gesture, something that can hardly be achieved today on modern handsets or PCs, and again perfectly integrated into the handset itself using the same gestures and same capabilities. The Pixel technology goes beyond just rendering individual pieces of content. Combining them is a unique capability of our architecture. This allows us, for example, to take the video and embed it within a web page. Now remember, this is more than 10 years old. This predates the concept of embedded video and YouTube as we see it today. In fact, uses a simpler and smarter architecture. Allow me to demonstrate. If we take that same magnifier that we saw earlier and place it over the video, you can see the video continues to become magnified, panning and zooming as you'd expect with a seamless UI. That wouldn't be achievable using the plugins that we use today, where two pieces of software attempt to share screen but know nothing about each other. And that's because of the graphical pipeline that's used in this technology. Add to that video telephony. Instead of being placed full screen, it can be overlaid semi-transparent on top of the web page. Now this is a crude demonstration and a crude UI, but it does show that independently panning and zooming multiple streams of content on the same device, changing the depth and transparency and repositioning them could be achieved even then without hardware, with standard content and standard video feeds. Taking an unoptimized port of a popular game at the time called Doom, embedding it within a PDF comic strip and allowing it to run live. Now this is running in demonstration mode, and as you can see, Doom is running in demonstration mode. It's not even aware of the fact that it is running inside a different environment. Superimposed on top of the game are controls, in this case touchscreen controls, to emulate those of a keyboard. If I were to interact with this game, I can start to play it using the touchscreen, just to demonstrate that the executable, the game itself, is fully interactable and it remains embedded within another piece of content. In fact, while running, we would be perfectly entitled to bring up that video, allow the video stream to continue, and allow the game to continue in the background, in fact watching our opponent perhaps as we throttle them. So a combination of video streams, video games, static content, all renderable using one single technology that could be applied in a multitude of ways and available for more than 10 years. The range of effects is quite wide and ever extending. For example, in this photo viewer, a simple demonstration of some of the effects can be seen. Water ripples, 3D effects with transitions and reflections, part screen and full screen. The behavior itself is fully programmable. The path, or the math path, that the animation will take and how it will enter and leave the screen can be programmed. So, for example, an overshoot or a bounce can be achieved with a simple change of the parameter. Here you can see that a small spring back and overshoot has been applied to the same transitions you saw. The UI itself includes some state-of-the-art 3D capabilities, including 3D models, again achieved without any specialized hardware. The same effect can be achieved on a non-touchscreen device, and again without making use of any specialized hardware, and as you can see, the performance is exceptional. One of the unique features of the user interface engine is that because it doesn't rely on specialized hardware pipelines, is that the various effects can stack themselves seamlessly. Here we see a simple spinning effect applied to a control, and when applied, continues to operate on the face itself as the face returns to its original 3D position. I'll demonstrate that again. As you can see, the spinning continues. That's significantly different from typical hardware OpenGL only based solutions, because although they can be made to do such things, they typically have specialized implementations to achieve that, or one-offs. Another feature of the way that the UI engine works is that because it's fully controlled using a clock, the timing of effects can be synchronized easily, even across two different screen sizes, two different platforms, and two different pieces of hardware. Watch the tumble as we see it sent through the device. Again, the application designer can concentrate on the user experience and not have to worry about the vagaries of each independent platform that they operate on. Different device, same UI platform. Cheap, easy to develop across multiple devices and form factors. User interfaces that normally take weeks or months take hours or days with Pixel's UIP. Grids that are capable of animating themselves into different positions or changing their look and feel with a simple touch of a button. And UI controls that can be developed with the least of effort. 3D carousels, photos, contacts, documents and pages, web browsing. UIs that can change dynamically even as you interact with them, because the parameters in the UI engine change, but the content is independent of the UI engine itself. The state-of-the-art UIs that take others months to develop take only hours or days.